Welcome to this video tutorial in which we are going to present you the experience we have developed over the last year designing and implementing an active learning methodology based on flipped learning at the University of the Basque Country by a teaching group of 12 teachers. To begin with, I will describe the context in which this project has been developed. The University of the Basque Country is dispersed in 3 campuses, located in 3 different provinces, and the Thermal Engineering Department teaches in the different degrees offered in 5 engineering faculties located in 5 different cities, to more than 800 students by a team of 12 teachers. In that context, it is necessary to coordinate not only contents, courses and teachers, but also methodologies. The implementation of the active learning methodological tools cannot be an individual effort, but rather a coordinated task. The educational innovative experiences based on individual leadership are not generating the expected real pedagogical innovation, and it became necessary to create a new pedagogical framework in which it is possible to join forces and involve all teachers in a coordinated action by a cooperative model of educational innovation. The proposal from the University of the Basque Country has been to create structured teaching teams characterized by a high degree of commitment with the student learning process, a high degree of coordination between teachers, and an intense use of active learning methodologies. But to address the most convenient methodology, it was necessary to reflect about what the STEM education is. In essence, any activity requires decision-making. The student itself is a decision-maker too. Each time he makes a step during the resolution of a problem or a lab experiment or a practical activity, he must ask himself why, what for, how and when is he making this step, using this equation, making this assumption, considering this simplification, using this model, or neglecting this effect. In our opinion, STEM literacy is not about being able to answer these questions rather than being able to make these questions. This is the way to build criterion. In the field of STEM education, the criterion requires science knowledge to understand the behavior of the complex real universe, technological knowledge to design and use tools to interact with the complex reality in our benefit, and mathematical knowledge as a language to simplify and modelize that complex reality to make it more manageable, more approachable, and more predictable. The traditional teaching is focused on the knowledge, supplying knowledge to the students, assuming that once they have knowledge enough, they will acquire spontaneously criterion, to someday being able to make decisions. Instead, in active learning, the focus is made on the learning process, training the students from the beginning on the decision-making through a practical and group activity, lab experience or problem-solving. During this process, during the decision-making process, the need for knowledge will emerge. After experiencing this process, the criterion will finally be built up, which was the objective. The process is inverted. The learning pyramid is inverted. After analyzing the different active learning methodologies, we decide to combine some of the existing active tools into a flipped learning methodology. Our proposal is based in 2 actions. By one side, we use mindfulness techniques at class in order to become the unconscious problem maker students, then to become a conscious decision makers. And by the other hand, the combination of different active learning tools in order to build a flipped learning methodology. The flipped learning methodology we have developed is based on 3 pillars. First, we aim to extract some of the theoretical concepts from the learning space at the classroom to the student individual learning space, building a flexible learning environment by a YouTube channel to be watched before the classroom. Second, A library of problems to be solved in class has been created according to guided problem-solving technique, in order then to be solved at the classroom in small groups by a collaborative activity under the guidance and assistance of the teacher, in order the student to practice and apply the concepts he has previously worked in his individual learning space. And finally, the monitorization of the whole learning process as a feedback activity. Prior to create the individual flexible learning space, the first decision to be made was what kind of contents should be extracted from the class to the YouTube channel. Two kinds of contents were found to be suitable for extraction. The first type of content were all mathematical demonstrations and developments that, being necessary knowing how to perform them, did not provide conceptual content. The second type of contents are all the animations used for a better understanding of the physical phenomena, processes, lab experiments, technology details, etc. The next question to be decided was the production format of the video tutorials. Three types of production format were used. On the one hand, the handwritten format for the mathematical developments, which are handwritten step by step in the same way the teacher would have done them on the blackboard in class. The second production format was the PowerPoint edited. When the complexity of the mathematical developments requires an equation editor or image files, this format is used. This format is appropriate for both content type 1 and type 2 video tutorials. Both production formats are appropriate depending on the type of content. According to the satisfaction questionnaires, students do not show more preference towards one or other format. The third type of production format combines video recordings, animations, and mathematical calculations. This type is used for practical experiences and simple experiments. YouTube Analytics provides several metrics that allow obtaining an audience pattern, as well as identify the impact that the video tutorial variables have, as for instance, production format, speaking rate, video length. All this information provides feedback in order to improve and redesign the video tutorials. For instance, the optimal video length is in between 8 and 10 minutes. In fact, what is important from this graph is that the audience keeps constant for video length intervals between 6 and 12 minutes. One of the reference studies we have based on when dealing with the production format is that of Guo et al., presented at the first AMC Conference on Learning at Scale, New York City, 2014. To our knowledge, it is one of the largest scale studies about audience engagement to date. Our video tutorials show a slightly higher audience engagement than similar Khan Academy-style video tutorials for all video lengths. One of the most useful metrics offered by YouTube Analytics is that related to audience retention. The absolute retention of the audience provides information on the retention of the audience in each instant of the video tutorial, in comparison with the total audience of the same video tutorial. On YouTube, it is usual for videos to have a high audience retention in the first 15 seconds of the video tutorial, and then a sudden drop in the audience. The video tutorials of the channel, however, have a fairly horizontal retention curve, which indicates that the audience is maintained throughout the duration of the whole video tutorial. In general, the retention of the audience remains constant throughout the duration of the video tutorials. There is a difference in the pattern of the audience between the regular lecture period, with an average retention of 61% of the audience, and the exam period, with an average retention of over 80%. The relative retention of the audience shows the capacity of a video tutorial to keep the audience watching it, compared to the rest of YouTube videos worldwide that have a similar duration. It can be observed that there is also a very different pattern on the relative audience during the lecture regular period and the exam period. The second pillar of the methodology consists of monitoring the progress of learning made in the individual learning space of the student to obtain the necessary feedback not only for the teacher but also for the student. The question was how to do this monitoring in an active and attractive way for the student as a group space activity. The solution we adopt was the Socrates-style quick response tools. In this way, the student can participate in monitoring using their own smartphone to complete in the first 10 minutes of class some questionnaires about the contents that they have previously seen individually in the YouTube channel. A library of questionnaires has been created by the group of teachers, so that this library is flexible to changes and improvements, accessible to all teachers and adapted to the needs of each subject. Before continuing with the lesson, the results are analyzed and discussed in group. This allows the teacher, the student, and the whole classroom to have a picture of their learning process in real time. All questionnaires results are recorded and shared for further analysis and statistics in order to have data for corrections. Students using the proposed methodology obtain a 10% better results on questionnaires than students under traditional methodology. The third pillar of the methodology consists on the practical application of the concepts previously worked by the student in the YouTube channel through a collaborative activity in the classroom. The technique of guided problem solving was chosen since, among other advantages, it fosters the decision-making process of the students. It fosters the discussion and analysis of problems under the guidance of the teacher, but giving prominence to the student. And it adapts well to the development of collaborative work. A library of problems has been created to solve according to the GPS technique, as well as their respective worksheets to guide the students and the teachers during the activity in the classroom. Regarding the results, we can say that the methodology has been applied for 1 academic year, and the first results show an average reduction of 9% in the failure rate and an increase of 0.65 in the average grades. These results are in consonance with the related literature and similar studies. Thank you very much for your attention.